Okay, the last bit that I want to summarize for you is this portion of the reading where it brings up a force versus time graph, or a force time graph. Now, we've looked at velocity versus time graphs already. I'm going to show you how to connect that velocity versus time graph to the force time graph. So let's say that we are looking at a velocity time graph that looks something like this. So looking at this velocity versus time graph, I can see that initially the object was stationary, it wasn't moving. Then it started to speed up, and then it moved at a constant speed, and then it slowed down. Now, in all of this, I'm trying to make my change in that velocity really constant. So these are meant to be linear straight lines. And then once it slowed down, it stayed stopped for a while. So the force time graph that corresponds to this same motion, I'm going to draw right below the velocity versus time graph. Now, one thing that I'm not sure comes up in the reading is the units for a force. The units for a force are given as an N when we're shorthanding it, and it's called a Newton, named after Isaac Newton, who is really credited with the 3 laws of motion that connect motion to forces that are acting on them. So when you're labeling your force versus time graph, you always want to include those units, and the units are newtons. Now, looking at my velocity versus time graph, if I see that there's no change in the velocity, in this case it's just stationary for, let's say, a second. There's no time points on this, so we're being very qualitative here. If it's just stationary, I know that its velocity isn't changing. So that means that for this first time point or second, there is 0 net force. And actually, that's one thing I'm going to specify here, is that when it says a force time graph, we're always talking about the net force, so the combined forces or the overall winning force. That'll come up in some later exercises and activities that we do, but I'm going to add one thing here, that this is representing F net. So we have 0 net forces for that first time point. So I'm going to add some vertical lines to really make sure I'm representing the same sequence of time. Then I see that it speeds up. If it's speeding up, then that means that there has to be an overall net force acting in the same direction that it was moving. Remember that the direction that an object is moving is shown as being in the positive part of the velocity time graph or the negative part. So if I look at this velocity time graph, it's moving in the positive direction the entire time because the velocity is positive the entire time. So that means I have to have a positive net force. That means I'm going to be in the positive part of this force time graph. And if it's a constant change in its velocity, so this is linear, that means we just have a constant force. So our force is going to be just a flat line somewhere in the positive quadrant of this force time graph. All right, next section of the graph, I see that I'm moving at a constant speed. No change in my velocity, so I can't have a net force acting on an object if the velocity is not changing. So that means we're back at 0. There's no net force acting on this object during that next part of the motion. All right, last part here is that we see that the object slows down. If it's slowing down, then it has to have an opposing force. Now, we have to talk about direction again. Since it's a positive velocity, it was still moving to the right here, let's say the positive direction. If I'm going to have an opposing force, that means that the force is pointing this direction back towards me. That would be the negative direction. So where we have to put our line on this force time graph is down in the negative part of this force axis. And again, it's just going to be a flat line because we see it's a constant rate of slowdown. So it's a linear decrease there. Okay, I said last section before, but we do have one more section where the object is stopped again. So when it's stopped, when its velocity isn't changing, back to 0 net force. If you have other questions related to these force time graphs, please reach out to your teachers. We're all posting our office hours starting the week after spring break, so you can access any teacher to get further clarification about these concepts.